The accompanying data are 45 commute times to work in minutes for workers of age 16 or older in Chicago. We want to construct a frequency distribution, and in this case we want to use a class width of 15 minutes and begin with a lower class limit of 0 minutes. And then, do the data amounts appear to have a normal distribution? And then examine the data and identify anything appearing to be unique. So the first thing we want to do is we want to put in our classes. Since we know the class width is 15, that means we have the first lower class limit is 0, and therefore this is going to be 15, which then makes this upper class limit 14. Therefore, this now, if we add 15 to 15, that's going to give us 30. Therefore, this is going to be 29. We're going to add 15 to 30, and that's going to give us 45, which then makes this upper class limit 44. Now, if we add 15 to 45, it's going to give us 60, which then makes this upper class limit 59. And therefore, we add 15 to 60, that's going to give us 75. And therefore, this is going to be 74. Now, how are we going to figure out what this number is? Well, we just need to add the class width. So if we take 74 and then add 15, that's going to give us 89, which is going to represent the upper class limit. Now we need to find the frequency of those classes. So we're going to click on the table here. Okay, and then we're going to find out how many do we have that are in between 0 and 14. So we have 1, 2, 3, 4, 5. So there's 5. Now between 15 and 29, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, between 30 and 44, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Between 45 and 59. 1, 2, 3, 4, 5, 6, 7. So it looks like 7. 60 to 74. We have 1, 2, 3, 4, 5. And then 75 to 89. We have 1, and it looks like 1. Now before we say we're done, we need to make sure that there's 45 commute times. So we need to add these up and make sure that we get 45. So if we take 5 plus 13 plus 12 plus 7 plus 5 plus 1, and that gives us 43. So must be missing something here. So let's go ahead and redo that again. So from 0 to 14, we have 1, 2, 3, 4, 5. Between 15 and 29, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there was my mistake. So we're going to put in 15. Now that we double checked, we know that we added 2 more. Let's check our answer, and there is our result. Now the next question says, does the data amounts appear to have a normal distribution? Okay, that means does it start small and does it increase, and then does it then decrease according to our amounts? So do we say yes because the frequencies start low, proceed to 1 or 2 high frequencies, which it does, then decrease to a low frequency, and the distribution is approximately symmetric? Okay, so we can say yes, and here it says the data that have an approximately normal distribution are characterized by a frequency distribution with the following features. Again, frequencies will start low, then increase to 1 or 2 high frequencies. Well, if you look at this data here, okay, it starts low, but it's not really low. It starts at 5. Then it goes to 15, 12, 7, and then 5, and then 1. So therefore, that is not the result. Now, do we say no because while the frequencies start low, they proceed to 1 or 2 high frequencies, then decrease to a low frequency, but the distribution is not symmetric? Do we say no because while the distribution is approximately symmetric, the frequencies start at a maximum and become low? Or it says no because the frequencies start at a maximum and become low, and then because the distribution is not symmetric. So we're going to say B. And therefore that is our result. And the reason why, again, is because it does start low, it does proceed to 1 or 2 high frequencies, and then decrease to a low frequency. The only thing is, it's not symmetric because these 2 numbers would have to be in the middle. The higher numbers would have to be in the middle for it to be approximately symmetric. Now we want to examine the data and identify anything appearing to be unique, and select all that apply. Well, the unusually large value of 80 minutes appears to be an error in recording the data. Based on the gaps in the distribution, the data appear to be from 2 different populations. There's no gaps there. Most of the data values are rounded to the nearest 5 or 10 minutes and may be estimates of actual commute times. That's not true. And the data are presented as quantitative, but are actually categorical, and that's not true. We do have a value that's 80 minutes. So we would say that that is an unusually large value, so we're going to select A to be our answer. Now, that is not our only answer, because it says at least one of your answers is incorrect, or you have not selected all the correct answers. Okay, so we know that 80 definitely is a number that could be an unusually large number. Okay, what else? Can we say most of the data are rounded to the nearest 5 or 10 minutes? Is that true? Well, let's check. Are they rounded to at least 5 or 10 minutes? That is true. So therefore, we would say that maybe C. So maybe A and C is our answer. And it says at least one of our answers is incorrect. So therefore, again, we want to make sure that are there any gaps? So are there any gaps? So this says the data are presented as quantitative, but that's not true. Now, does their data appear to be from 2 different populations? Are there gaps? Well, let's go ahead and click on that. And the answer is C. The accompanying data are 45 commute times to work in minutes for workers of age 16 or older in Chicago. We want to construct a frequency distribution. We want to use a class width of 15 minutes and then begin with a lower class limit of 0 minutes. Do the data amounts appear to have a normal distribution? And then we want to examine the data and identify anything appearing to be unique. Well, the first thing is we want to be able to identify our classes. And it's telling us that our class width is 15. So that means that we're going to go from 0 to 15, and then from 15 to 30. 30 plus 15 is 45. and 45 plus 15 is 60, and 15 plus 60 is going to give us 75. Now the number here is going to be one lower than the 15, so we're going to start with 14. One number lower than 30 is going to be 29. One number lower than 45 is going to give us 44. And actually, let's add. What's 14 plus 15? Well, that's 29. What's 44 plus 15? Well, let's go ahead and do that. Since that's the class width, 44 plus 15 gives us 59. We know this is going to be 74 because that's one less of 75. And now let's go ahead and take 74 and then add 15, which is the class width, and that gives us 89. Okay? So now we have our classes. Now we want to identify the frequency by looking at the table. So now we need to find all the numbers between 0 and 14. So if we go down here, we have 1, 2, 3, 4. So we have 4. Between 15 and 29, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15. Now 30 to 44. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. Let's go from 45 to 59. 1, 2, 3, 4, 5, 6, 7. There's 7. 60 to 74. 1, 2, 3, 4, 5. So there's 5. And 75 to 89. We have 1. So it looks like 1. Now, before we check our answer, we want to make sure that we have the total frequency, which should match the amount of commute times, which is 45. So let's add that up first to make sure we're correct. So we got 4 plus 15 plus 13 plus 7 plus 5 plus 1, and that gives us 45, and that matches. So we should be okay, and therefore there is our result. Okay, now it says, do the data amounts appear to have a normal distribution? Okay, now if it was a normal distribution, okay, now it means that it would have to have all the data that are in the center, and then it should be symmetric. Now, it starts low, but not super low, and then it's high pretty quick, and then it gets low again. But it doesn't necessarily mean that the high numbers are in the middle, so it's not going to be a symmetric looking kind of figure. So, what we're going to say is the following. It says, note, because while the frequencies start low, proceed to 1 or 2 high frequencies, and then decrease to a low frequency, the distribution is not symmetric. We're going to click that one. Now, then it says, yes, because the frequencies start low, proceed to 1 or 2 high frequencies, then decrease to a low frequency, and the distribution is approximately symmetric. Well, it's not symmetric because these numbers would have to be in the next lower cell to make it sort of in the middle, to make it a possibly symmetric. So in this case, the answer is going to be no for the first part. Now it says, examine the data and identify anything appearing to be unique and select all that apply. Okay, it says, Most of the data values are rounded to the nearest 5 or 10 minutes and may be estimates of actual commute times. Well, that's possible because they are ending in 0 or 5, so we can go ahead and click that. The data are presented as quantitative, but are actually categorical. That's not true because these are numbers, they're numerical measures. Based on the gaps in the distribution, the data appear to be from two different populations. We don't have any gaps in here. There aren't zeros, so there's no gaps. And it says the unusually large value of 80 minutes appears to be an error in recording the data. Well, not necessarily, because it's not that far off from the 60 minutes. So our answer is going to be